And welcome to another video. In this video we are going to solve problem number 981, that is time-based key value store. In this problem, design a time-based key value data structure that can store multiple values for the same key at different timestamps and retrieve the key's value at a certain timestamp. Okay, we need to create a data structure, so it should store key value pairs. So for a particular key, there will be multiple values with timestamp actually. So when we get a set request, so set request includes a key and a value and timestamp value, and a get request will just get the key and they will pass a timestamp. We need to return the first value for that key for which timestamp is less than or equal to this particular timestamp, whatever the timestamp that they are passing. So these are all the requirements. I am also solving this problem for the first time and I just want to try this problem out. So let us start with initializing these data structures. So whenever they call init, we will initialize what we can do is we can initialize a dictionary named key value. So this is a dictionary. Initially it will be empty. So whenever they send a set request, what we are going to do is key value of, and they are going to send a key value of key dot append. Okay, here we have to append along with the value, we are going to append timestamp as well. So set is really simple. We will just insert the value along with the timestamp for that dictionary. Set is really simple. But what happens when the get request comes? So for get request comes, if there are no values, we should return an empty string. So if key in key value, if we have, okay, I think we are directly writing, since this is a part of that particular object, we should use it with the self. If key is in self.key value, then only we will proceed to do some search, start searching for that timestamp. Otherwise what we are going to do is we will just return empty string. So what happens if the key is present? We need to return a value for that particular key. So for the first value which satisfies this condition, for this first value with the timestamp less than or equal to the timestamp that we are passing, so we will get, first we will get all the values. So values will be equal to self dot key value of value, not value, key. So these values will be consisting of all the timestamps. From these timestamps we have to return the largest. So return a value such that if there are multiple such values, it returns value associated with that largest timestamp previous. Okay, we have to return the largest value which is largest values. We got the values. Now what we should do is we will start iterating over these values. Left will be 0. Anyway, we are searching for a particular timestamp, and in that particular timestamp we should len of values -1, as long as we have a valid range, while left is less than or equal to right. Now let us say we largest value, largest timestamp value index, let us initialize it to -1, largest timestamp value index. This will be updated in this particular while loop when we start doing the binary search. So we will compute the mid, that is left plus right divided by 2. Once we have the mid, we can check whether our values of mid, this will be a tuple. From that tuple we are pushing timestamp. So first value 0th index will represent the value, and first index will if this timestamp is less than or equal to our timestamp whatever that we are trying to query. So we have this. Then if that is the case, then we may have a valid key. So largest timestamp value index becomes mid, but we have to search in the right range as well for better answers. So our left will become mid plus 1. So this is if our first mid satisfies this condition. So if mid satisfies this condition, okay, otherwise we just have to start searching in the right equal to mid minus 1 range. So after this we will check whether our largest timestamp index is still minus 1. That time we will return minus 1. Otherwise we can return values of so this is the index that we are getting, largest timestamp index, and largest timestamp index of 0. Let us submit this solution and check whether the solution is working. I think we missed the point where I'm just thinking now. So we are assuming that these timestamps are in increasing order. If that is not the case, then it becomes very difficult to implement this solution. Okay, what it is saying. Okay, we are having some runtime error, key value of I'm not understanding what is the runtime error that is showing. Okay, we will check here as well. If key value, then we are going to append. If key is in self dot key value. I think without key it is failing, else we will just initialize with the list. So self dot key value of key equals, we will have a list with that tuple, value and timestamp. Let us see if it works. I am assuming like whatever the set calls they are calling with this increasing values of timestamps. Okay, we have some typo here. Largest timestamp. I hope we are using, okay. Okay, where it is failing, everywhere we are getting null. So how that is possible? Maybe this binary search itself is going wrong. So let us say there are some values 1, 2, 3 and 4, 3, 4, 5 and 6, and they are giving a query named 4, let us say 3. So we want to return what is the first value which is much greater than 3. So when we hit the mid, there are possibilities that, okay, left will become mid plus 1, and this is a possible answer. Okay, otherwise if mid fails that condition, then we will start searching in the range of mid minus 1. But everywhere we are getting okay, here it is not minus 1, we should return an empty string. Let us check this again, but I'm not understanding why we are not. Everywhere we are getting null. What may be the issue? So it gets called, and then we are calling this set. For every time set is called, either we append if key is already present, otherwise we are going to create a tuple. So let us start printing these things. After every call we are going to print self dot key value. I think this gives us better idea instead of trying to figure out. Printing this dictionary will give us a clear idea about what is happening here. So let us run this again and go through some test cases. Okay, timestamp, and then we call a set. So okay, why? Okay, foo, for the key they are saying foo and bar and 1. Okay, it makes sense. And then they are calling get with a foo 1. So if our timestamp is less than or equal to timestamp, okay, these will be the tuples, and for the mid we are calculating the mid, and mid is also a tuple and first value. Okay, what we should get here? Ideally expected is bar. Okay, that is the value. It makes sense. Whenever we get a 1, what is happening here? When we get 1, it is already present here. So we get the values and we'll start the left and right thing. If the middle element is less than or equal to timestamp, okay, mid becomes 0. Okay, I'm not really understanding where we are going wrong. So even here, okay, these are all the get requests. When we get the first set request, it is appending this value. That is fine. When we get this request, it should have return bar, instead we are getting null. So that is what I'm trying to understand. Okay, here we have just written this statement. We haven't done anything. This is one of the difficult things with the Python. So even if there are some errors, we will not be able to catch it during the compile time or something like that. Only we will get more runtime errors in Python. Okay, our first test case is passing now. Let us stop printing these things because we just started printing it. When we try to debug this thing. Let us submit this solution and check whether it is passing all the test cases. Wow, it is passing all the test cases. So here is the solution that we have done, and let us discuss about time and space complexity. For this method, if you want to insert something, here we are for the total solution that we have implemented. What is the time complexity? We cannot calculate for here. If we want to, this method runs in of one time because we are just creating an empty dictionary. This is also accessing a key and putting values. This also runs in of 1. So memory wise we are using those many keys and whatever the value. So memory, that is space complexity. Space complexity is O of key plus values. That is, if there are k keys, we need k keys for storing, and v will be the length of the values. What is the time complexity? For time complexity, for get method we can discuss, because that is the only place we have implemented this thing, binary search. Time complexity, at worst case there may be only one key and all the values will be inserted into it. So that time it becomes O of log n. N is the number of values which are present. So this is the time complexity. I hope this makes sense. Thanks for watching this video. If you are interested in learning more about other data structures and algorithms, you can consider checking out other videos from my channel.